We are in section 1.3, which is going to cover equations with variables on both sides. Now before we begin, and this is not in your book, but I wanted to give you a little hint, and I'm going to give you a checklist to show you the steps that you need to take in order to solve a multi-stepped equation. So I want you to write these down first. Here are your steps. Number 1, get rid of parentheses. Get rid of all your parentheses. Now, if that's the case, more than likely you're going to have to distribute. And distributing is when you take something outside and multiply it to everything inside to get rid of your parentheses. Combining like terms. Combine like terms means to simplify both sides of your equation. So you want to combine everything before you start moving things across the equation. Third, move the variables to one side. If you have variables on either side of the equation, which is what we're going to do today, you have to move them down to one side. And lastly, use inverse operations to solve. So that's going to be finishing up solving like a two-step equation. So let's do an example. Variables on both sides. Let's try 5x minus 2 equals 4x plus 6. Now in this problem, I want you to understand that you have variables on both sides. Here's a variable 5x. Here's a variable 4x. The one thing that I do not ever want you to do, and don't ever do this, you cannot take 4x plus 5x and get 9x. The reason you can't do that is because the variables are not on the same side. If they're not on the same side, you need to start moving things. Now, if you look, there are 4 terms here. You have a 5x, a negative 2, a 4x, and a positive 6. I could take this 5x and do the opposite, which is minus 5x, and move it over. I could do the opposite of this minus 2, which is plus 2, and move it over. I could take this 4x and do the opposite, which is minus 4x, and move it over this way. I could take this plus 6 and subtract 6 on both sides and move it over to the left. So you have 4 things that you can move in any direction as long as you do the opposite to move it across this equal sign. But because the x's are my main concern, that's what I'm going to do first. So I usually move the smallest value coefficient. So I move the variable that has the smallest coefficient. In this case, it's the 4x. So how do you move a plus 4x? Because this is a plus. There's a plus here. That's a plus 4x. You do the opposite of plus 4x, which is minus 4x. So then I subtract 4x over here because that's like terms. I put it underneath the 5x. And now all I do is simplify. 5x minus 4x is 1x. The minus 2 comes down. 4x minus 4x, the whole purpose was for me to move it to the left, so that's gone, equals 6. And now I have an easy one-step equation. The opposite of minus 2 is plus 2. So that gives me x equals 8. And that's my answer. X equals 8. Example number 1. I'm going to do this 2 separate ways. So I'm going to show you both ways that you can solve this problem. And then I'm going to show you the way that some people do that's wrong. So look at example 1 and write this down. 15 minus 2x equals negative 7. What I want you to do is solve this equation. Now if you notice there are no parentheses to get rid of, there are no like terms, so I have to move the x's to one side. So you can either move the negative 2x to this side or the negative 7x over to the left. Well, because there's only an x over here, I'm going to take this minus 2x and move it over to the right. So what do I have to move? I have to move a minus 2x. The opposite of minus 2x is add 2x. So that would give me 15 equals, because the x is canceled, the negative 2x plus 2x cancels, negative 7x plus 2x. Now here's the deal. If you don't know what that's going to be, if you think it's going to be 9 or negative 9, you don't know your integers well enough. So make sure you study. Negative 7x plus 2x. These signs are different, so we subtract them. That gives me negative 5x. I took 7 minus 2 and got 5. Because there are more negatives, that's going to be a negative 5x. So now I have to get rid of a times negative 5. This should be really easy now. It's a one-step equation. Times negative 5. The opposite of times negative 5 is divide by negative 5. And that negative 5 divided by negative 5 is just 1x. 15 divided by negative 5 is negative 3. And that is my answer. The next problem I'm going to use, but I'm going to move the minus 7x. So, how do I move a minus 7x? I could add a 7x. That would give me 15. Now this is where some people go wrong. I'm going to do it down here, but this is wrong. Some people take 15 and they're like, oh, well, negative 2x plus 7x. That's just 7 minus 2. That's going to be 5x. I divide by 5 and it's equal to 3. That is not correct. If you notice, that plus 7x is now to the left. So 15 plus 5x should all be on the same side. If you look at, here's your equal sign. This is going to be on the left side of the equation. So 7x minus 2x is plus 5x, and then the equal sign. And then negative 7x plus 7x, there's nothing left. So what's there? It's a 0. So now I need to do a two-step equation. I need to move the 15 over. The opposite of 15 is subtract 15. That gives me 5x equals negative 15. Divide both sides by 5 because that's the opposite of times 5. And negative 15 divided by 5 is negative 3. So if you notice, either way gives you the exact same answer of x equals negative 3. Example number 2. 6 times the quantity 4 minus z equals 2z. Step 1. Get rid of your parentheses. This is a review from 7th grade. How do you do that? You distribute. So that means you take 6 times 4 and 6 times negative z. So 6 times 4 is 24. 6 times negative 1z is negative 6z. Because 6 times 1 is 6. 6 times negative 1 is negative 6. So now my equation is 24 minus 6z equals 2z. I want to get my letters on both sides, that are on both sides now, onto one side. So I'm going to move the minus 6z. How do I get rid of a minus 6z? I add 6z. So that would give me 24. 2z plus 6z is 8z. Divide both sides by 8. That gives me z equals positive 3. And that's my answer. Fairly easy. Get rid of your parentheses and start solving your equation. Example number 3. Example number 3. Negative 2 times the quantity x minus 5 equals 6 times the quantity 2 minus 1/2 x. Get rid of your parentheses. What are you going to have to do? Distribute. So negative 2 times x is negative 2x. Negative 2 times negative 5 is plus 10. These are all rules of integers. So if you're being confused by these, how I'm getting these numbers, you don't know your integers well enough, so you need to study. 6 times 2 is 12. 6, this is not a half, this is negative a half. 6 times negative 1/2, well, what's 1/2 of 6? It's 3, so it's minus 3x. And if you get confused by that, 6 times 1 is 6, divided by 2 is 3. So now I have variables on both sides. Well, I'm going to move the minus 3x. You could move the minus 2x. What's the opposite of minus 3x? Be plus 3x. So I'm going to put the plus 3x under this x term since they're like terms. So then 3x minus 2x just gives me x. Plus 10 equals 12. I now subtract 10 on both sides. X equals 2. Here's your new key idea. This is brand new. You need to write this down. Every equation, from elementary school to junior high so far, you have solved equations that equal one solution. And by one solution, I mean only one value that makes it true. X equals 9. X equals negative 2. x equals 3.5. Those are all one solution. However, some equations do not have one solution. Equations can also have no solution or infinitely many. So here's your two key ideas to determine which one's which. When solving an equation that has no solution, you will obtain an equivalent equation that is not true. So you will get an equation like 0 equals 2. If you get two numbers that are not equal, like 0 and 2, your equation is no solution. Now notice where the variable is. We don't have any. So both of these are only when the variable cancels. Only. That is it. Only when the variables cancel. Now when you solve an equation that has infinitely many solutions, you will obtain an equivalent equation that is true, such as 2 equals 2, 5 equals 5, 9 equals 9, negative 3 equals negative 3. That would give you everything would work, infinitely many solutions. So let's do some examples. Example number 4. 3 minus 4x equals negative 7 minus 4x. Step 1, get rid of parentheses. We don't have any. Step 2, combine like terms. We don't have any. Neither side can be simplified. Now I need to move my variables to one side, so I'm going to move the minus 4x. The opposite of minus 4x is plus 4x. You will notice this is the only time that you will get no solutions or many solutions, is when the variables will cancel. Since I added 4x to both sides, the variables are completely gone. So I'm left with 3 equals negative 7. Well, 3 does not equal negative 7. So because 3 equals negative 7 is never true, the answer is no solution. I'm done. Example number 5. 6x plus 4 equals 4 times, in parentheses, 3 halves x plus 1. 6x plus 4 equals 4 times, in parentheses, 3 halves x plus 1. First step, get rid of your parentheses. So 6x plus 4 stays the same. So now I distribute the 4. 4 times 3 halves, 4 times 1. So whenever you multiply a fraction, 4 times 3. 4 times 3 is 12. 12 halves, or 12 divided by 2, will give me 6x. 4 times 1 is 4. Notice, already both sides are equal. They're exactly the same. So if I subtract 6x on both sides, they're gone. That leaves me 4 equals 4. Because 4 does equal 4, your answer is infinitely many solutions. What does that mean? That means if you plug in anything for x, right here or right here, it would always be true. Always. No matter what you plug in. 1, 5, 9, 10, 3 halves, 7.9, negative 3.27. No matter what you plug in, it would make that equation true. Let's try another example. Number 6. 1/2 times 6t minus 4 equals 3t minus 2. Distribute the 1/2. 1/2 times 6 is 3t. 1/2 of negative 4 is negative 2. Equals 3t minus 2. Notice both sides are the same. If I subtract 3t, because the opposite of plus t is minus 3t, we're left with negative 2 equals negative 2. That is true. So our answer would be infinitely many solutions, because negative 2 does equal itself. Example number 7. 6 times 5 minus 2v equals negative 4 times 3v plus 1. I distribute the 6. You get 30 minus 12v equals, distribute the negative 4. Negative 4 times 3 is negative 12v. Negative 4 times 1 is negative 4. So I need to move the 12s on both sides, so I'm going to do the opposite of minus 12v, which is add 12v. That gives me 30 equals negative 4. That will never be true. Therefore, your answer is no solution. Once again, make note that anytime you have no solution or many solutions, the variable will always cancel. Now your pop quiz that I'm going to give you tomorrow morning will say this. On your pop quiz, I'm not going to check your notes because you could have copied your notes. So I'm going to check this. If I'm going to put on the board something like 3 equals 3 and 3 equals 2, and I'm going to tell you when the variable cancels and you are left with either one of these, tell me which one is no solution or many solutions. And you would say, well, because this one is equal, 3 equals 3, that would be many solutions. And 3 equals 2, that would be no solution because they are never equal. Now keep in mind, if you are ever left something like this, x equals 9, the variable didn't cancel, this is always going to be the one solution. Which you've been doing that since elementary school, solving one-step equations where you get one solution. So keep in mind, this lesson, what do we go over? We understood that if we have variables on both sides, you do the inverse operation, you do the opposite to move the variable to one side. And also we learned about no solutions and many solutions.